So in this section we're going to look at factoring and all kinds of different ways to do that. And so let's just do a few examples here. One is I've got this cubic guy, and we're not sure exactly how to factor all our cubics, but if we can factor something out that can get us to x squared, we have a lot of different options. In this case, I can factor out an x. So when I pull that x out, that leaves me with x squared plus 2x minus 15. And now I can go through all of my tricks that I've got for factoring a quadratic. And so this has a leading coefficient of 1. So I just look at those things that make 15 that subtract to 2. And it's going to be 3 and 5. So my factored form is going to be x times x and x, 3 and 5. And I need my 3 and 5 to add or subtract to 2. And in order to get that, I'm going to have a minus 3 and a plus 5. And there's the first guy. On the second guy, the same thing again. We're looking for something that's common in both. I don't know how to factor a fifth-powered polynomial, but I know that once I can get to a quadratic, I have a lot of different ways that I can factor a quadratic. So on this guy, let's take out a 2y to the third. I can factor that out. And when I factor out 2y to the third, what am I left with? Y squared minus 9. And when I do that, the y squared minus 9, those are two perfect squares in there, and it's going to factor to this. 2y cubed times y plus 3 times y minus 3. And again, I just need to figure out a way to get down to a quadratic form. And once I can do that, life just gets real nice. Well, let's look at that last guy. I got 4z to the fourth, 16z cubed, and 16z squared. And so on this last guy, I can take out a 4z squared. And when I do that, that gets me down to a quadratic z squared minus 4z plus 4, which is 4z squared times z minus 2 times z minus 2. And most answers that you find, like on a standardized test, aren't going to look this way. So this would be 4z squared times z minus 2 squared. And so that's how you factor something completely. If you just look for a way that you can factor some things out first and then go from there. And you've got all sorts of tricks once you get to a quadratic. You can use the quadratic formula. You can use slide and divide. You could use the box. You could use all kinds of different tricks. But the main thing here is to get to something that you can get down to a quadratic so you can use them. Okay, so these are the sum and difference of cubes. They're really an easy pattern to remember, but you'll need to have them memorized for your test. It's not a horrible thing, but it is a little bit different. And so when you factor these two guys, basically what you need to see is whether you've got plus or minus. And if you've got plus, then all you're going to do is look at the cube root of x, of x cubed, which is 3, and the cube root of 64, which is 4. And if I have x cubed plus 64, then when it factors to x plus 4, and then x squared minus, these two signs have to be the opposite, and then 4 times x, and then plus 4 squared. So these two signs have to be the opposite. And if you'll notice up here, those two signs are the opposite in both ways. Okay? And then if I have a plus x cubed plus something, then when that first step is x cubed plus, or x plus, and then the minus is next. So it's not it really isn't bad, and you can practice these. You can do a lot of these over and over again until you start to catch the pattern. But you'll need to have these memorized when you take a test. Okay, so this one's a little bit more difficult, and I don't have a way to factor z to the fifth, but I can look in here, and I've got 16z to the fifth and 250z squared. And what I'm going to try and do is at least factor out a 2 and a z squared, because I can get 2 from both of those. So when I take my 2z squared out, I'm left with 8z cubed minus 125. And this guy right here looks like this guy right here. So 125 is 5 cubed, and 8, let's see here, 2z is 8z cubed. So there's my two pieces. And so what I'm going to end up with is 2z squared times, and then since I've got minuses, okay, I'm going to have a minus here. So this would be 2z minus 5 times 4z squared, and then the opposite sign, plus, and then multiply those two guys together, 10z plus 25. And that's all there is to it. Okay, now again, I don't know how to handle an x cubed, and I'm looking at this guy, and there's nothing that I can factor out of each piece. So what we want to do is we want to do what's called factor by grouping, and we're just going to split this guy up into two pieces, and we're going to look for common things in both pieces. Okay, so when I do this, in that first piece, I see that I've got an x squared. So what I'm going to do is, in this first group right here, I'm going to factor out an x squared. That's going to leave me with x minus 3. And in the second group, I'm going to factor out a negative 4. And when I do that, that leaves me with x minus 3. And you'll notice now that I've got an x minus 3 here and an x minus 3 here, and I can factor that guy out. And when I factor that guy out, I'll be left with my x squared minus 4. Now pay attention, because we want to factor this thing completely, and x squared minus 4 factors one more time. And you've got to be able to catch this later on a quiz or a test, so this would be something you might just need to practice this problem a couple times, but this will go all the way down to x plus 2, x minus 2. And once you get to a quadratic, once you get to your quadratic here, use your quadratic formula, or check and see if it'll factor, even if there's a 0 for a middle term. But if we're going to factor something completely, we've got to pay attention to these things. And the grouping, you're just looking for different things that you can factor out. In this case, it was the x squared and the 4. And then what's left should also factor, which was the x minus 3 and x minus 3. Grouping looks a little bit different, but it's the same exact process for factoring that we've been doing all year. All right, so let's factor these two guys completely. Well, look at the 16, x to the 4th minus 81. That looks to me like a 4x squared and a 9 squared. And so when we're factoring a, this is actually going to come down to 4x squared plus 9, and then 4x squared minus 9. And looking at these guys, these are still quadratics, so will this guy factor? And you could try the quadratic formula and some different things, and he doesn't. But this guy does. Because again, I've got the difference of two squares. So when you look at that guy, I've got 2x squared and 3 squared. And if you have a difference of perfect squares, they factor. And so what this is going to give me is 4x squared plus 9 times 2x plus 3 and 2x minus 3. On this bottom guy, I'm not sure how to handle anything to the 8th power. I'm not sure how to factor something to the 8th power, but there's a 2p squared in every piece. So I'm going to pull 2p squared out. And when I do that, I'm going to end up with p to the 4th plus 10p cubed. No, p to the 6th, sorry. Plus 10p to the 3rd plus 6. Oh, good Lord. This should be 5p, and this should be 5p. And again, I'm not sure how to factor something to the 6th, but this looks to me that if I were to think of it a little bit different way, like a quadratic-ish, like something like x squared plus 5x plus 6, does that factor? And it does to x plus 3, x plus 2. Well, in this case, my x's aren't x's. My x's are p cubes. P cubes. And so this guy will factor one more time. And so I've got 2p squared times p to the 3rd, because p to the 3rd times p to the 3rd is p to the 6th. So p to the 3rd times p to the 3rd. And then what times what is 6? That adds to 5. And that's where you get 3 and 2. Now this is a toughie, and it can be really hard to see, but the big clue is this. My degree, when I factor out, is a 6. My next term is half of that. And so if I have that leading term has a power of 6 on it, and the very next term is half that power, I have something that may factor. Then I just need to go and check my last number there and see if it's something that will factor. And in this case, it turns out that it does. So again, another one of those problems where if you just practice just this one problem a couple of times and look for some different things that are going on, you'll be able to do it. All right, so on this last example, we want to find the solutions for 3x to the 5th plus 15x equals 18x cubed. And so one of the things that you can do on this is go ahead and move that 18x cubed over to the left. And when you do that, graph it and find where it crosses the x-axis. That's an important value. And if you graph it and look at it on your calculator, this will give you some calculator practice, but also it'll tell you what numbers you're looking for, because you also will need to factor this out by hand and do it. And sometimes if you know where you're going, it can be a little bit easier. So I've got 3x to the 5th minus 18x cubed plus 15x. And notice that I've got a 3x in each one of these terms. So pull that 3x out. Not 3x to the 4th anymore, but x to the 4th minus 6x squared plus 5. And if you'll look at this guy right here, this has a shape of, a look of, something along the lines of x squared minus 6x plus 5. Remember, we said if this first exponent, whatever that first exponent is, if the very next term had an exponent that was half that it could factor, just like we would factor a quadratic, and this is the shape that it would take. And so what we're going to look at is just factoring x squared minus 6x plus 5, which is going to factor to x minus 5 times x minus 1. And that's exactly how this other guy is going to factor the same exact way. So check this out. I'm going to have 3x times x squared, because what times what is x to the fourth? And it's got to be x squared. And then what times what is 5? Well, it's got to be 5 and 1. And the only way to get to that -6 is to put the -1s in there. Now, on this guy, what you'll need to do is factor it completely. And so notice this is a difference of perfect squares. So we've got one more factoring step. And then once you have this done, you'll set each piece equal to 0. So you're going to set that 3x to equal to 0. You're going to set the next guy equal to 0. You're going to set the next guy equal to 0. And you're going to set the last guy equal to 0. And you're going to set each one of these things equal to 0 and solve it out. So what you're going to end up with is 3x equals 0. Well, that just gives us x equals 0. The next one's a little bit weird, but hang in there. It's not bad. You just do what it says. X squared minus 5 equals 0. Well, add 5 to both sides, and then take a square root. And don't forget, when you take a square root, you get plus or minus. And so on this one, x equals plus or minus the square root of 5. And if you forget that plus or minus, you're going to miss one of your potential answers. So always have that plus or minus written down. The next one is going to be x plus 1 equals 0. So x equals -1. And then the last guy is going to be x minus 1 equals 0. And x equals 1. Now, let's count off answers here. 1, 2, 3, 4, 5 answers, which is good because we have a 5th degree polynomial. And if you have a 5th degree polynomial, you should have an answer for every degree. So this guy's done. And if you punched it in on your calculator and found all 5 zeros, these were the numbers that you found. And that square root of 5 would have been a decimal. So factoring is really important. It can help you solve these guys out and take a complicated, yucky problem, but get very reasonable, good solutions.